So now we can also change from mixed radicals to entire radicals. Now it's just working our way backwards. So often working our way backwards yields some complete thoughts that help us out. Now we know that the nth root of a times b, we can split it up into the nth root of a times the nth root of b. So here what we're going to simply do is I'm just going to use this backwards. I'm just going to say the nth root of a times the nth root of b. Well, we can bring that under the same radical sign, and we can say that is the nth root of a times b. Fair enough. So 8 times root 2. Now, the index of my root is 2. So really, this is 8 times the square root of 2. Wouldn't it be nice if I could make 8 a square root? And in fact, what I do know is 8 is equal to the square root of 64. So here I take a look at my coefficient and I need to change it to a square root. And the square root of 64 is 8 times the square root of 2. So now I'm just left with, since my radicals have the same index, I can bring them under one radicand and multiply them. So the square root of 64 times 2 is equal to the square root of 128. So again, I saw the product. I needed to change my constant so that it was a root with the same index as my other roots. So it was a square root. And then I know that the 8 is equal to the square root of 64, and I just plug that in, substitute the square root of 64 for 8. Now let's continue to the next example. Now 4 root 3. Now again, this is square root. But in my mind, I think of this as 4 times the square root of 3. Now 4 is equal to the square root of 16. So this is where it's definitely helpful to have a knowledge of perfect squares. So now I could write the square root of 16, which is really 4, times the square root of 3. Now since my radicals have the same index, the square root, I can simply bring both radicands under the same radical. So the square root of 16 times 3, well, that is equal to the square root of 48. So 4 root 3 is equal to the square root of 48. Let's go on to something a little bit more serious. They're all the same. Who am I kidding? 14. Now, this one might be a challenge. So really, I'm just going to write it as there. 14 times the root of 2. I do this, I spread it apart to make it clear in my mind that I'm dealing with the coefficient and the radical. Now, I believe 14 times 14 yeah. In other words, I know that 14 squared is 196. Now, if I know that these 14 squared is 196, this implies that the square root of 196 is equal to 14. So I know that the square root of 14 is the square root of 196 times the root of 2. Now I just need to multiply these two together and I am done. So I'm going to rewrite this as 196 times 2. And I'm sure at home you're complaining, why am I doing this? Long form multiplication, which is nice. The square root of 196 ends up being 392. And really that's all there is to it.